Nokia Mobile Networks Technical Center. So me, myself, and our colleagues hosting you today, we are working with making this campus and the surroundings active place for business and people. And therefore, we welcome you warmly to visit Nokia and bring us energy, new information, and extremely interesting topic for everybody to discuss today. So Nokia has been here in this site for, I guess, from 70s. This is the Nokia headquarters. We have all the business units present in this campus in several buildings. We have more than 3,000 people working in the campus, of course, remotely. Portion their weeks as well, but 3,200, I guess, is the number of the people here when it comes to Nokia personnel. We have very international campus. We have 84 different nationalities working in this campus. So therefore, what I see here, very international audience as well. We need talents when it comes to Nokia, and we need talents for Finland as well. So excellent to have you all here. About arrangements, so we had already pizza, so pizza is a lot of plates left still. So please go ahead and take still more energy. The facilities, the toilets are over there when you arrive. That's in a kind of behind the screens, big screens over there, 25 meters that way. And you have the badges. As we go further with the program, when you leave, if you leave your badge over there at the reception at the time of the end of the event. Anything, if you have questions, please come to us, arrangers and organizers. If you have any questions, you can freely wander around in this restaurant area. So that's totally open for us. So once again, welcome to Nokia, and let's have a nice, interesting event.
Thank you. Okay, then let's talk a bit about what will happen today. So the theme of the night is Thesis. So all the speakers who are speaking today wrote a thesis about cloud-native technology, and they will talk about some related topics. And thanks for the speakers. We are very grateful to have you here. Okay, I should keep it like this close. Okay, cool. All right, so this meetup is part of the Cloud Native Nordics meetup group, because we are, like in open source, like to gather into different groups. The Cloud Native Nordics group is particularly a network of meetups, so we are helping each other with organizer tools. We are sometimes sharing speakers. We have a common Slack channel where we discuss topics which are relevant for the whole Nordics. Interesting thing for Finland is that there are 3 meetups about CNCF in Finland. So there is one in Turku and there is one in Tampere. So if you are from there, or if you know people in these cities, then please notify them or yourself that there are these meetup groups, and these are also very good places to meet and discuss about cloud-native technologies. We are constantly growing, so that means the meetup group counts at more than 1,500 members in meetup, which is very good. I'm very happy to learn that more and more people are joining to the meetups. Can you show with a show of hands who is first timer in meetups? Yay! Okay, welcome everybody. Welcome. That's very good. So for you and for the others also, I have to say that we are following the CNCF and the Linux Foundation's Code of Conduct, which practically means that be nice to each other and don't hurt each other, but I think there will be no problem with that. And of course, you can also join to the Cloud Native Nordics community. We have a web page, we have a Slack channel, we have a GitHub, so all of these you can find or you can ask us to give you the pointers. There are lots of interesting discussions are happening in these channels. And of course, as every meetup group, we are constantly looking for speakers and we are constantly looking for sponsors. So if you would like to talk about something which relates to CNCF or CNCF projects or cloud-native technology, yes?
So at these talks, is there any type of like proceedings that will be published afterwards if we give talks here, or will they be recorded, or like, will there be like, can you like incentivize us to give a talk? Because some of us only do it when forced.
It is live stream.
Okay, yeah, live stream is probably fine.
Yes, so the question was that...
and do we need to submit like a paper, like an archive preprint, or like nothing like this? We can
Just
okay.
whatever.
Because Cornell's like review committee, they suck, so it's better.
Okay, just to repeat the question and answers. Like the question was that is there any recordings or proceedings of the talks, or what are the incentives for the speakers to speak? The answer is the meetups are live streamed, like this one also in the YouTube channel and recorded in the YouTube channel of the Cloud Native Nordics. And how to submit talks, I think that was the second question. I think the answer is that talk to us or follow that link.
Or what if the paper is like longer than like a lightning talk, like maybe like 11, 12 pages long or something like this? Does it matter?
If the paper is longer than the frame of the meetup, then I think we should talk like we can figure out something. But if it's like a long...
30 minutes.
Yeah, 30 minutes is the max. If it's a longer or a stronger proposal, then maybe like KubeCon is a better option.
And do we have to like run the experiments live, or can we just like talk about like the data that we get?
Can you repeat?
Like, would we need to like run experiments live or something?
No, if you have a video of something, then that is also okay. Like if you have a demo or something,
Right, okay.
everybody does that.
Again,
So, yeah.
It depends on how much thrill you want as a speaker.
Exactly. All right, any other comments or questions? And I think this is a good example of how we would like to run the meetup. So anytime you have any questions or comments, just speak up and we can discuss. That's the main point of this whole thing. All right, then we are not just part of Cloud Native Nordics, we are also part of CNCF, and this whole Cloud Native movement is started from CNCF, and it's about projects, open source projects hosted in CNCF. So CNCF is the Cloud Native Computing Foundation. It was founded in 2015, and its mission is to practically make Cloud Native accessible for everybody and advertise Cloud Native technology and help the communities to develop the Cloud Native technology. And this is an organization where lots of open source projects are hosted, for example, like Kubernetes, Helm, Prometheus, just to name a couple of famous ones. But it is not only like a bunch of coders, like there is a lots of processes, there are lots of committees, and there is a lots of organization happening to help these communities to work together and produce the projects in a healthy manner.
Is SIG special interest group, like end user special interest group?
Yes, exactly. SIG is special interest group. And CNCF have this project maturity model. This is for the users practically to be able to figure out how much they can trust in the maturity of the projects. And the approach in CNCF is that the entry point to sandbox level is very easy. So a project can become a sandbox CNCF project very easy. But then growing to incubating, that is a bit more difficult one. And if you would like to jump to graduated, that is a very big jump. So practically that means that if a project is graduated, then it is ready for production, and you can trust that it is working, it has backward compatibility, it has support and all of that. If something is incubating, then a bit less, and if it's sandbox, it's not. You cannot be even sure that the project will be there in a year. So that's somehow the different levels. And here are the logos for you. So like you can see that there are lots of projects, for example, which are already graduated. And I just learned that now there are 4 more than this 20 in this slide. So they are graduating very quickly. Like the project state is defined or evaluated by the technical oversight committee of CNCF. So they decide if a project is graduated or it's a sandbox. So it's like they decide on how the project is moving on this slope. So there are lots of incubating projects. Maybe you can find your favorite projects here. And there are lots of sandbox projects. All of these you can see from the CNCF website. So CNCF, on top of like just managing the projects, they are doing lots of work on supporting the ecosystem. One thing what they do is this landscape. So this is a web application, and you can like here search for different open source projects or different other projects related to cloud native technologies. You can do different filters and all of that. It's a very scary landscape. It has whatever, like more than 1,000 projects, but it's a very good way to see how spread the technology is.
So is this like, these look like a collection of like Y Combinator companies that have gotten some, is that what this is?
No, it's not just companies. It is like open source projects,
right. So
products,
these
companies.
Are the byproduct of some incubator that you're running?
Yes.
Oh, okay, just to be clear.
CNCF also produces user tech radars, which are practically like analysis of like new technologies and how these different projects and technologies can be put into this adopt, trial, and access dimensions. And they are doing this every year for different topics like CI/CD, database, secret management, and so on and so on. So all of this is useful if you are new to the area and just you would like to see which projects are for you, what project you should try. These tech radars are very useful to recognize that a new technology is coming and a new project is coming. And I let Lucas to talk about the rest of the things.
Almost. Hi, from me as well. I'm Lucas, and then we also have Anni, Mariam, and Edna is actually taking a call from the other organizer. So yes, a little bit about the different trainings and other stuff that CNCF helps with. They generally kind of help the project succeed in many different ways, as for documentation and governance and process and legal and all that kind of stuff. But this is also one way to create certifications, trainings, all open on the web that you can check out. And some of the, or like to get certified, it costs a little bit of a couple of €100, but it's quite worth it. They also have the MOOC, the massive online open course, which is for free. So these are very popular. They start with the for Kubernetes. They start with the Kubernetes certified application developer. Then the second step is administrator, CKA, and then the kind of most advanced one is the security specialist. But they also have in all kinds of other areas. So these form a good way to kind of get started with all of the things that this entails. Of course, you can keep coming to these meetups and learn more about their ad hoc, but there they have kind of very structured and also in kind of training format. Then if you are a company that want to show your excellence and your training kind of possibilities and what all the kind of things you can offer your customers, then you can also, if you have now it's 3 actually, 3 people in your organization that has passed the Kubernetes certified administrator exam, then you can, together with some other requirements, enroll the Kubernetes certified service provider program. And there's quite a lot of those there. If you are providing a Kubernetes conformant solution to your customers, then you might also want to certify it and publicly show that this is kind of the open Kubernetes according to these baselines. Essentially, in order to get this stamp, you need to run whatever, couple of hundreds end-to-end tests in the cluster and show that the end-to-end tests actually work in the way that they should. So that kind of allows people to know that if you have applications on one place, then you can also transfer them to Kubernetes clusters in other places or from other vendors. So that's that. And then for the kind of all the kind of things that you can do with the community.
All the fun stuff. Yeah, hi everyone, I'm Annie, as Lucas mentioned there before. So there's a lot of things happening with CNCF that you can get involved with. Obviously, you can come to these local meetups, which is a great way to just, join in on the fun, have some pizza, it's quite nice. But there's a lot of, interesting stuff as well. So they have a page for Meet Our Ambassadors. So there's an X amount of ambassadors globally who are very excited about these technologies, who are always willing to talk. I am one and Lucas is one as well. So we are always happy to talk if you need, or any of the organizers here, to be honest, as well, or other people. There's mentorship programs, so there's a lot of things you can tap into there as well. There's cloud native community groups, which is one of these, for example, local meetup events. There's Kubernetes community days, for example, Denmark has one coming up and so forth. And then we have KubeCon plus Cloud Native Con, which are then the next slide. So they are the large international, the global ones, but the KCDs are usually per country or per city. And then for the KubeCon, the next one is going to be in Chicago, very exciting. Very looking forward to going to Windy City, and that's obviously in November. The North America one, if anyone wants to join. Yeah?
Is there a call for abstracts for this?
There was. It's already done, unfortunately.
What? But you were advertising it. It's not fair.
Yeah, well, at this one I'm advertising for attending, so anyone can go there and attend. But I can tell you that the next Europe one is coming as well, and the call for papers I think is opening end of this month-ish.
It's September 18th.
Yes, September 18th, so that, keep your eyes peeled there. So that's going to be in Paris then in the springtime. And usually, if you are looking to then submit to the North America one, the North America CFP should be open around the time when this event is going on as well, so during the springtime as well. But all the dates you can find from the KubeCon website and whatnot, so all the stuff is there. But obviously you can attend the Chicago one, that's very cool. But for most people, obviously the Paris is a bit closer, so you can just visit a bit easier and whatnot. And early bird tickets and whatnot are usually quite good, well priced as well. And usually all the events also have a virtual attendance option. So you can get a virtual ticket to check out the program or whatnot before this as well. But in my opinion, the best part though is all of the sessions from KubeCons will also be recorded and available online. You can find them from CNCF YouTube. So if there's a session that you want to check out, or if you want to see, what kind of sessions are there in the events, you can go to CNCF. You will find every single KubeCon session for the last, over 5 years. 2016 or so. So there's a lot definitely to learn, get inspired for your own sessions as well if you're interested. Yeah, but I think that's mostly it. If you want to reach out to us, we have a GitHub, Slack, YouTube, all of these things. Or you can just come here and talk to us face to face. That's nice as well. Thanks everyone.
And then just a little bit of look into the future of the meetups. Here we have the agenda for the fall. So Supermetrics, October 4th. Next time, then we have Relax at November 22nd. Then Yleisradio in January 18th. And Alpha Sense in February at some point. So we're looking, again, as Gergely said in the beginning, if you like to speak at these kind of January, February events, then we'd be more than happy to have you as well. So that's kind of very excited about these in the fall. Hope to see you there as well. But then I think we will take a 5-10 minutes, a little bit of a break, then we set up the next speaker and let's go.
Yeah.
Thank you. This is actually the same.
There's probably still some food as well, so if anyone wants to grab,
Yeah, get more food if you want.
yeah, for the next session.
and I'm a platform security architect at Nokia. And today I'm going to just give a high-level introduction of Talos Linux, the Kubernetes operating system. So now first let's start with overview, that what is Talos? So based on Talos actually website, what is Talos is a container optimized Linux distribution, which is designed to be secure, minimal, and immutable. But Talos has one purpose, and the purpose is hosting Kubernetes clusters.
Very close to you.
Yeah. So, okay. The purpose of Talos is to host Kubernetes clusters. So it is not like general purpose or generic operating system that we can just do whatever we want with it. So the purpose of Talos, it is like that it is just used for operating Kubernetes cluster. So what is it that we are saying that Talos is integrated with Kubernetes? So it is like that, for example, if we have bare metal machine and if we install Talos, then yeah, we have Talos and Kubernetes. But is it enough really? Does it make sense that we mentioned that Talos is really good? There are also other reasons that why Talos is good. So yeah, so why we should use Talos? What is? The first one is like that Talos is minimal, because we say that Talos has only one purpose, and it is like that to host Kubernetes clusters. So it is not like that. So what we have is like that we have necessary binaries and services for managing the operating system and Kubernetes. So what does it mean? It's just like that if we just look at, okay, I will mention, so we ignore this part because I will explain later, but if we look at that Talos, that for example in the binary path of Talos, what we can see that it is like just limited binaries. We have containerd, which is used for as a container runtime for our Kubernetes. So there is no package manager. What does it mean? It means that after we have Talos, we cannot just, okay, we say that, yeah, I want to install this package, or I want to have, for example, this binary, so let's just install in Talos. So there is no package manager. So it is like that, what binaries we have, it is what we need for Kubernetes. And it is not a generic OS. And if we compare it with a generic OS, we can see that, for example, I have a Ubuntu, I just put a screenshot of, I think that a quarter of my binaries in Ubuntu. So you can compare that this binary in generic we have, so we can see that it is not for a generic OS. And the other reason that why Talos is API driven. So it is like that APIs perform system management tasks. So it is like that, for example, if I want to see that, for example, what interfaces I have, it is just like that I should use this Talos CTL tool, and everything is based on this system management, for example, for checking that, for example, fetching these kernel logs, we can just use Talos CTL. So it is not like that we can just log into Talos and we just go ahead and just go to this log folder and see that, okay, what are the logs? It is like that whatever we want, it is based on API. So for the system management and other things, so we have APIs. And these APIs are secure with MTLS, so mutual TLS. And it's not like the REST API, it is like gRPC. So I will explain here more detail about this Talos component, but here you can see that, for example, I have control plane node, I have, for example, if we ignore this part, so we can see that when Talos control plane node want to talk to worker nodes, so everything is based on this gRPC API. And also for operator to talk to and, for example, interact with OS, everything is based on APIs. And all these APIs are secure with MTLS. It is not like that we just check that, okay, server, what is yours, for example, certificate. Both client and server check the certificate. So we have this mutual TLS here. And the other thing, Talos is immutable. So what does it mean? It means that we cannot change it after deployment. We have this Talos image. It has, for example, binaries and everything, and we cannot change it after deployment. And we have a read-only root file system. And the point with this immutability is like that, because when we configure it, so there is no, it eliminates this configuration drift. It's not like that, for example, some people just change the configuration. So we don't have it, it's immutable. We cannot change, for example, Talos after we deploy it. And it is declarative. So what is it? It means that it's really cool thing that all the configuration, it's done through a single YAM file, and which is this machine config file. For example, here we can see that all the configuration, if I want to configure my network and everything, it's not like that, okay, I should remember that, for example, where is the path for network, where I should configure my network. Everything is in one config file. For example, for network, even for Kubernetes, for even encrypting disk, everything is in one config file. And actually, it makes this cloning and deployment much easier, because when we have this configure file and when we install Talos, then voila, we have Talos the same, for example, we deploy it in some other places. So the other thing, why Talos? Talos is secure. So it is hardened in configuration. It is using this guideline of best practice of Kubernetes CIS, which is like the Center of Information Security. For kernel, it is using KSPP, which means that kernel self-protection project. So it is like that Talos, it is hardened in configuration. So it is using, for Kubernetes, it is using this guideline and best practices of the CIS benchmark. And because it is minimal, so we don't have that much binary and server services which are vulnerable. So because of this, and because it's immutable, we cannot change it after deployment, so we kind of reduce this attack service. It's not like that, for example, Ubuntu can be, for example, we have one binary, it is safe, but the other binary can cause some problem, for example, in Ubuntu and make it vulnerable. But for Talos, because it is minimal and immutable, it actually reduces this attack surface. And there is no shell or console access. So I cannot log into Talos, I cannot SSH to Talos. And why it is like this? Because, as I mentioned, because it is API driven, so even access to Talos should be based on secure with MTLS. So because it's API driven, so there is no need to have shell or console access. And the other point is like that Talos is consistent across environment. It supports cloud, bare metal, and virtualization platforms. Okay, here in that declarative part, I mentioned that this machine configuration file, so it is better that we just have a deeper look at it. So this node configuration part actually is the most critical file in OS, and it has all these options and configuration that we need to set up a machine. And as I mentioned that, for example, here we can see we are saying that this is this control plane node. About this CA information, for example, about kubelet, about network, and I just put just some part of this configuration, but that you just get the idea that everything is configured based on this file. And also, I mentioned that, for example, I mentioned that, I was using this Talos CTL tool to just work with Talos. So here, let's see that. What is Talos CTL tool? Talos CTL tool, actually, it is used that we can interact with OS, with our operating system, and it is like that interface between, for example, operator and Talos API. And here you can see that, for example, there is some command that we can use to interact with our OS. For example, here we can just get like this, manage this CRI container images. Here, for example, we can upgrade Talos, we can upgrade the Kubernetes, this rebooting, and yeah, you see it has a lot of cool commands. And for interacting, we just need to use this talos.ctl file. talos.ctl. Okay, so I mentioned that everything is every access should be secure with MTLS. So also for accessing this, this talos.ctl tool, it is used that when operator it is using like this talos API, and client also should authorize him or herself. So how we do it, we use this talos config file, which is like this client configuration file. And here you can see that, for example, we are mentioning that, yeah, what endpoint we want to access, and client should also have the certificate and key. And because it is a mutual TLS, so the certificate of client should be signed from the same CA, root CA, as the server. And here you can see that what are these part of this talos config file. For example, here that endpoints, nodes, the CA certificate, and client certificate and key. So when we have this file, we are authorizing ourselves, and then Talos API can understand that if we are authorized to use this, for example, the services to manage operating system or not. Okay, so till here it was about this Talos config file, and now let's talk about Talos components. As here you can see that, for example, here there is this operator, and operator to just interact with OS, we need to use talos.ctl, and for authorizing ourselves, we need the talos config. And here in this part, in for example this control plane node, we can see that we have Linux kernel. So this is the core of this Talos operating system, and it has this KSPP recommendation, which is kernel self protection project. For example, in this one, for example, we have PTI on, which means that this page table isolation is on in this Talos. So this kernel, it is like that based on this best practice recommendation. Then we have APID. So here you can see that this operator, this APID, it's listening on this port, and also here is for control plane node, and also for worker node we also have this APID listening. So what is this APID? It is like actually this API endpoint in Talos. So APID just fetch all the requests and serves as a gateway. So for example here, I'm an operator, I just want to even change something, for example, get the list of files in one worker node. It is like that I just send my command, and then here you can see that from control plane node, APID just fetch the request, realize that, yeah, okay, where this request should go, if it should just send it to machine D component of the same node, or no, for example, if it should send it to APID of the worker node. So here you can see that, and again, this API is secure with MTLS. And then we have machine D component. This is kind of this init process of Talos that when when the kernel give the control to Talos, this is this machine D that just start execution, and it handles all this machine configuration, API handling. So here you can see that APID is just sending requests to machine D. Then machine D just realized that, okay, so let's see that what I should do, for example, with this request. Is it for container D, or is it for example, network configuration? And this machine D is also managing this resource and controller that we have in our Talos operating system. And then the next component is container D. So container D is our container runtime in Talos. And then we have network D. This network D is responsible for this network configuration. So we have like this node config file, which we said that, yeah, for example, you should use this configuration for network, and network D is responsible for just executing all this network configuration. And then we have trust D, Actually, this trustee is this root of trust in Talos. For example, it has critical role in PKI. And then we have UWD, which is like this Talos device file manager. Okay, so these are like this Talos component, and here you can see that, for example, for this Kubernetes cluster and this Talos part, they are separated from each other. This Talos part is just listening in this port, and Kubernetes, it is API server is listening in, for example, this 6443. And yes, and for accessing, for example, Kubernetes cluster, I should have kubeconfig, and which is different from this Talos config. So even this certificate and key for client is different. So you can see that they are separated. And here we also saw it that this APID is just work as a gateway and just send the request, for example, to the APID of the worker node, or no, for example, for this, if it send it for the other component of Talos. Okay, so now I just, it was like kind of like this overview of Talos, but then I thought that maybe it is a good idea that we just also know a little about that, how is this disk encryption in Talos operating system. So maybe it can be, we can just be deeper in one part of Talos. So here, we said that we want to see that how is this disk encryption. So first we should see that what are these disk partition that we want to like protect it against attacker. So Talos operating system, you know, our disk partition contains 6 parts: ephemeral partition, state partition, meta, boot, BIOS, and EFI. This ephemeral partition is mounted to this -var directory. It contains this workload data of pods, containers, this Kubernetes cluster, and it may contain this sensitive workload data. And then in this state partition, we have like, it has this node config file. And we mentioned that this node config file has all the configuration. It has also these keys, secrets, and certificate. So we definitely should really protect this file, because if an attacker just get access to this file, so it can just see that even what is our root CA key, for example, what secrets we are using. So we definitely should, for example, protect this part. And then this meta partition, it is a block device. It is just like including vectors of tag and values. And what it's one of its kind of like use case for this meta partition is just like that when we are using a state partition, it contains this state partition encryption config. So it is like that we have like this meta partition and this state, which is like this one, this which has like this node config file. It has this state partition encryption config. And then we have this boot partition, which contains like this initramfs, kernel. And then we have BIOS or EFI. It depends that if we are using UEFI bootloader or we're just using this BIOS. So it is like that. It has, for example, this EFI partition, it has this UEFI bootloader. So these are this disk partition, and so we definitely now we know that we should, if for example we have like one attacker and just the attacker just get access to this part. So you see it get access to all this operating system, because can even change or just read these secrets. So now Talos is using LUKS, which is Linux Unified Key Store. So it is using, you know, this LUKS is implementing encryption of data content in Talos. And here you can see now that, for example, I had like this Talos bare metal, and then I tried to boot another operating system, which we say that is unauthorized operating system, to my machine. And then here you can see that when attacker tries to read try to read these partitions, it is encrypted, and we cannot get access to this one. For example, these partitions. And these encryption keys types, again, are configured in this config file. So here you can see that we are saying that, yeah, this is the system disk encryption for this ephemeral part, and Tolos just support this, the encryption of ephemeral and state partition. And for example, here we are saying that, yeah, what kind of key we are using. So here I will mention later that what is node ID and static. So here you can see that in our config file, we are also putting this configuration for this system disk encryption. So now let's check that what are the encryption key type. First, it is a static, which is like this exactly plain format of key passphrases in the machine configuration file. So it is not safe at all. So you see that the passphrase is just there. As you can see that, for example, here we just mentioned that, yeah, this is my passphrase. Okay, and then the next part is node ID part. Node ID is it is generated from this UUID of the machine. So what we can do is like that if some attacker, for example, just remove the disk and put it in another machine, the attacker cannot read the content of disk. Why? Because the UUID of machine is different. So this node ID is just like that. Here you can see that there is nothing, it's just empty structure. But when we kind of use it, we are just saying that, yeah, our key is this node UUID of the machine. But this one is also not safe because we can get access to this node UUID. And now in the latest release of Tolos, they are kind of introducing TPM stored key. So our key is stored in TPM. And Tolos, and here you can see that this is this new type, TPM, and because now Tolos is supporting secure boot. And if we just use this key for this, for example, if we just, the key that we are using for encryption, it is stored in TPM, and we also enable secure boot, then we can kind of seal this decryption of our key to this TPM state. So in this case, the secure boot can lead to trusted boot in Tolos. So here we can say that, so if you want to use disk encryption in Tolos, go with this latest part, because these two are not safe. And yeah, in this latest release of Tolos, actually, it is supporting this secure boot, which is really a cool thing. So yeah, it was just this. So if you have any question, I'm happy to answer. Yeah, sure.
So I haven't taken an operating systems class. I'm just going to throw this at you. Like, can you say more about process management with respect to this particular operating system?
What do you mean, this process management?
How threads, how certain, how processes are, distributed to specific for computation. Unless this is so trivial, it shouldn't be addressed.
Yeah. It is like that. This machine D, that the component of machine D. So here you can see that this machine D is exactly like this init, and whatever we have here, so everything it is cloned from this machine D and the processes. Yeah.
I see. And I'm like, let's say, this is another random question, but what if there's a bad config or something? Because it seems, I checked out postmortems for most companies. It seems like most issues are just bad configs.
Yeah. So this bad config, it is like that. Actually, it is bad as you are mentioning. That and there is no checking that how is this configuration. It is just we are trusting this operator to, and there are this best practice in Tolos, this Tolos website, that you can see that how it is better that you configure it. But then you are the one that actually configuring. So it can be bad configuration as well. So it is like that when I have this file, this config file. So Tolos give me some default, but then I am the one that I can add or remove some configuration. For example, here you can see that here by default, so there was only one interface. And here I'm adding, for example, another interface. I'm setting that what IP address it's used. So if there is this bad configuration, then yeah, then the operator did the bad thing. So
I would suggest to store your config in a Git repo, so you can always roll back. One question from my side, like, how do you still customize it? Like, if you would like to have like this CNI or that CNI.
it's like that. Actually, here in, for example, here for this CNI, I mentioned that yeah, I want to use flannel, but you can also in the configuration file mention it that what CNI you want to use. And it also, if for example for customizing, there is also opportunity that you can customize, like for example this kernel and init ramfs. So there is a way that, but then you need to build your image. But for this CNI, so it is like mentioned in configuration file that what you want to use, what is this, for example, this image that you want to use, and everything. So everything is in this machine config file. Yeah. Yeah, sure.
Is there support for additional devices such as GPU, which might require
Yes.
drivers
Yes.
for kernel?
Yes. In Talos website, they also mentioned that you can use, but here maybe I can show you this Talos website, but yeah, they are supporting GPU. And here it is actually, their site now, it's really cool. I remember that when I started 2 years ago, it wasn't that much straightforward. But here you can see that in this documentation, they are using, you can use GPU as well. If I can.
Disaster recovery.
Okay, yeah, here you can see.
Yeah, click that.
So here you can use also GPU for your operating system. Yes?
Yeah, I was wondering, you mentioned read-only file system. What about logs? I mean, or in regular situations and so,
Mhm.
like, you know, in general, the logs of
Please repeat the question.
Yeah.
I don't hear it.
Yeah, if you can repeat, because I also didn't.
Oh, you like.
Yeah, I also didn't hear. I
okay.
just heard some audit likes.
I mean, on the Talos cluster, Kubernetes audit logs from master nodes,
Yes.
and also generally logs of containers. How about that?
Yes, it is like that. You can get, for example, let me show you that. But you can get these logs. They are stored in this ephemeral partition, and you can also stream them to, for example, what services that you want to use, if it is like Falco or if it is also other thing. But yeah, the logs are in this ephemeral partition, and you can also read the logs of your Kubernetes cluster as well as this Talos component. And then from them, you can just stream it to, for example, this audit logging microservice.
Streaming, there should be some shipper that is running on the nodes then that ships, right? What size
but-
log?
As you
Yeah,
get a Kubernetes cluster with Talos, you can install anything that works
Yeah.
normally on Kubernetes. Anyway.
Yeah, and I remember that, for example, for this Falco, that it was like that this driver of it that you can install, you can customize it, and then you see even in this base level, you can just, this driver is just listening, for example, to everything, and then you can just send it to this audit log service. Yes, what else? Oh, yes.
Do they have atomic upgrades? I mean, if, for example, for some reason they missed some driver and you upgrade Talos, and it didn't run to the user space. So if there is like some missing
Yeah, there is always this recovery and rollback, if there is some fault. But if you want to I didn't get it, that if you want to have your own customized driver, you can also add that customized driver to your, for example, init ramfs.
For example, all these upgrade system, so you need to upgrade the kernel.
Mhm.
This usually comes to the reboot. And the first thing that you start, so it's you start
Mhm.
user mode. But
Yeah, yeah, yeah,
such
yeah.
situation, I mean, usually upgrades should be atomic in terms of like you put into an EEPROM.
Yes, actually this upgrade has like this rollback that if something happen, it is not just like that, that when, for example, even if you get the image, maybe even the image is wrong. So it is like that, that when you have this upgrade like request, and if something goes wrong, it goes to this previous stable option. So it just roll back to this previous one, and it wouldn't just, just upgrade to the faulty version. There is like this rollback for upgrade.
So do they use model?
Mm,
Because you need from images.
yes, it is like that. For example, in this bootloader, when they are bringing that in this boot option, they have like it become like this A and B upgrade part, and it is like that. That this A is this stable one, and if something goes wrong with this B upgrade part, then it just move again to the A. So in this, for example, in this BIOS and EFI part or in this kernel part, we have actually two part that, yeah, if something goes wrong, then it just fetch, goes through this stable version of Talos. Yeah.
It's actually really cool. Like if you have a prototype GPU and you're actually internal at NVIDIA, I mean, this is actually, there's utility to this.
Yeah. Yeah, they are really doing a lot of cool stuff, Talos, and they're just progressing day by day.
That's interesting.
Yeah.
Thank you very much.
All right, then let's have now 15 minutes break and talk to each other and drink beer and eat more pizza if you want to, and let's continue 6:30.
Let's start with my presentation now about state of the WASM ecosystem and creating your own components to abstract away application and plugin development. So, my name is Yerzhan Zhamashev, and I'm a student at Aalto University, finished Digital Systems and Design, and currently studying for a master's degree at Aalto University Computer Science. Currently also building a web ecosystem for one of the labs at Aalto University. And at this event, looking forward to expand my horizons together with all of you. And thank you for coming here. So, the topic of this presentation is about my thesis and the project work, so the theoretical and practical part. In the first half, I'll talk about what is WASM and what is WASI and its relevance, WASM use cases. And for my project work, I will talk about issues when working with WASM and current workarounds that exist, and which tools can be used to right now build WASM applications, and what awaits next for WASM in the future. So to adjust my speech right now for the audience, I would like to ask how many people here know what WebAssembly is?
Can you say more about it?
Yeah, I'll talk about it, just making sure that, yeah, so that's quite a bit, but not a lot. So, yeah. So WebAssembly is a binary executable format, which is currently accepted by all major browsers. And it can be executed alongside JavaScript for WebAssembly is a new way of executing code in all major browsers right now, and the specification of WASM is maintained by the World Wide Web Consortium, the organization which is responsible for standardizing all the browser features. And WebAssembly by itself cannot do anything useful. It requires a defined interface between the host runtime and the WASM module so that they can communicate with each other. To run any application or library written in almost any language inside the browser, tools such as mscripten can be used to compile WASM for example, C, C++ into WASM. For Rust, there are other tools like I don't remember right now, but and similar tools exist for Zig, but for languages like Python or JavaScript, it would be difficult to compile it into WebAssembly because you have to compile the whole interpreter together with it. So WebAssembly only is a low-level bytecode that can be executed inside web application inside browsers. Any questions about this right now? So WASM, because it's a low-level bytecode, it can be also executed outside the browsers if there is another host runtime installed on the hardware. And because, for example, when you are working with mscripten, it offers really non-standardized interface for communicating with the host runtime, and the WebAssembly working group created WASI for. I'm so sorry. Yes.
Do you have any code snippets by any chance coming up in the next couple of slides?
Yes, I will be showcasing my demo of how creating WASM components. So I can continue next. WebAssembly is becoming more and more relevant in the field. In my research for use cases of WASM, I searched for literature, and year by year, literature regarding WASM is increasing.
So are these real papers or just like archive papers?
These are real papers that are.
Okay, but
yes.
only on ACM and IEEE.
Yes, yes,
okay.
ACM and IEEE.
Very sweet.
So, as part of my thesis, I explored the use cases of WASM, especially in Internet of Things, and I identified 8 use cases. First 4 are the most interesting ones. It's for WASM can be used for building function as a service platforms, for application offloading and migration systems, hardware resource access management, and application runtime at an operating system level. And some minor ones is remote device software debugging, application runtime for trusted execution environment, IoT software deployment system, and on-target intermediary representation.
So like MLIR, right?
How?
So for like MLIR, like an extensible compiler.
What do you mean by that?
So like, okay, LLVM is like this monolithic compiler, but MLIR is some extensible.
Yeah.
Intermediate representations are extensible.
Actually,
so
yes.
Are you talking about compilers as a service at the cloud?
Not right now, and I will not be talking about that.
Can you say more about the 8th point in general?
So yeah, WebAssembly can be also perceived as an intermediary representation, just like LLVM.
Right, but is it monolithic like LLVM?
I do not know what means monolithic, but...
Right, so like, okay, so now MLIR is extensible, so it's not just like a monolithic intermediate representation.
I do not understand it.
So, okay, so you're talking about on-target IRs at compiler and runtime. Are you referring to LLVM or MLIR?
No, treating WebAssembly as an intermediate representation.
Okay, so can you say more about that intermediate representation?
Sorry, it's
like a JVM.
I'm getting really confused and I'm really sure what he's saying.
Yeah.
Can we maybe save these really technical questions to the end?
No, I was just asking him about, I was just asking if you could say more about the intermediate representation.
That's cool, because I'm now completely lost. He's having a really hard job to keep going, so...
No, but it's actually directly related to it.
I know, that's cool, but can we let him talk?
Yeah, no, I'm letting him talk.
Thank you.
This is directly relevant.
Yeah, I'm sorry, this is my first presentation, so I'm new to this, and hopefully this will go.
It's going great.
Yes.
It's going great. Let's keep.
Yeah, and also disclaimer: this is a bachelor's degree thesis, and I have.
I thought this was your PhD.
No.
Okay.
Of course.
Okay.
So first is a function as a service. Yes, and now I'm going into detail for the first 4, but I will skip the last 4. For building function as a service, I found 4 literature, and one of them utilized Node.js runtime to build an alternative to Apache OpenWhisk. If you're familiar with Apache OpenWhisk, it uses usually Docker to execute these functions. So they built this alternative, and they observed that even though they are using Node.js, which is interpreted and it is slow, the cold start times were significantly faster, and they were able to avoid like long waiting times. And then second, literature built a custom runtime completely from scratch using Rust and a system around it, which was even more significantly faster. And a fourth literature that I found integrated WASM directly into Apache OpenWhisk. So they created an interface for Apache OpenWhisk to use WASM interface instead of Docker. So this way they kept the old technology of Apache OpenWhisk while already integrating WASM into the system. So they observed all of them observed significantly faster cold start times compared to container-based or virtual machine-based technologies or like microkernels. And it also makes execution of chains of functions isolated from each other even more performant. For example, if you have a directed acyclic graph, for example in AWS Lambda, each Lambda function is going to be executed with significant cold start time, but with WebAssembly you are going to skip all those cold start times significantly. And it is they also observed that it is easier to manage resource allocation for the invoked functions because WebAssembly uses a very simple linear memory, and there is no complicated memory management system in the specification. And so it is possible to allocate, to specify how much memory it should use, how long it should run, and how the execution should be scheduled. The runtime in the WASM module takes kilobytes of data, while VM and container-based images for running functions can take tens or hundreds of megabytes in size, while this is just a bytecode. Similarly, running containers or VMs consume a lot of memory on the host for virtualization and every other task, while WASM is more lightweight. However, of course, WASM lacks features like access to hardware acceleration, garbage collection, and other features that can be achieved more easily using other programming languages, which are more like high level. And one other literature notes that WASM can already be integrated with Docker. If you have seen that Docker already provides a shim for executing WASM instead of Docker containers. And there are already new systems like WASM Cloud and Spin used for orchestrating WASM microservices or functions. Based on this and the previous slide, we can see that now I'll skip this. And the next one is application offloading and migration. So it's a system to migrate a snapshot of an application from one host to another, and then continue execution from a new place. So first literature was released in 2019, where they offloaded WASM execution from the browser to as a web worker to a server, and then the consequent literature already talks about app migration using custom interface and a host runtime, and also extending existing runtimes, WASM runtimes, with migration functionality. And they also observed that WASM is more lightweight than using, for example, JavaScript or C# or Java, and then pausing it and migrating it to another target while it is being executed, because all of them involve a lot of complicated memory management system, while WASM is more minimalistic, so it is easier to deal with. And next one is hardware resource access control system. As I mentioned in the FAS use case, it is easier to manage what WebAssembly gets access, what hardware resources WebAssembly gets access to, and similarly, it can be used, for example, in IoT devices. And if you provide your IoT device runtime for WebAssembly with access control spec sheet, each application can be configured to access certain sensors or actuators only, or use certain amount of battery usage. So that I found one literature regarding that. And the next one is integrating the application runtime at an operating system level. It also gets close to the idea of treating WebAssembly as an intermediary representation. So when integrating WebAssembly directly into the operating system, you skip the overhead of translating the system calls, because you are running the runtime, and then the runtime translates it to the system calls, and you are going back and forth.
Nice, yeah.
And here, instead, you are integrating it directly into the operating system, and it becomes more performant, because that's one issue with WebAssembly, interfacing with it, and with its very limited linear memory. And also, it is possible to integrate the operating system to directly access some, to integrate it with some cloud computing, with some cloud services to download and verify WASM code and then execute it on target. And then this brings to the question how WebAssembly can be compiled on target. Just like in the browser, it can be compiled ahead of time or just in time, but it is better to compile it ahead of time, because there is no need to do it just in time. It doesn't have to be executed immediately. And regarding ahead of time compilation, I found some literature where they were able to compile WebAssembly on Atmega 128 with 4 kilobytes of RAM and 128 kilobytes of flash memory, while another page presents good compilation performance on Atmel SAM 3X8, which is an ARM Cortex M3 processor, which can be found on Arduino Due. So as you can see, WebAssembly can target a lot of different hardware, and it can be compiled on very resource-constrained devices because it's so lightweight. So next, I will talk about my project work, where I tried to make a simple, fast solution using WASM. And my goal was very simple, is to trigger a WASM code to process an HTTP request upon receiving it. So while designing the system, the main problem I stumbled upon is that WASI sockets ABI is not yet integrated into the standard libraries and compilation toolchain of C++, C, and Rust. So if you have a HTTP server, it is not currently possible to just compile it and run it in WebAssembly with WASI interface. And of course, there are also problems related to asynchronous execution threads, and the WASM and WASI specification is also evolving. That's why the WASI sockets ABI is still unstable, and it is not yet accepted into the standard library as of now. So there are different solutions proposed by some runtimes. For example, WASM Edge, which is a sandbox project of CNCF. They offer Rust standard library network replacements, and also alongside they provide patched versions of popular HTTP libraries in Rust. And this can be used only with WASM Edge runtime. And WASM runtime forks the WASI repository with all its specification while it was in preview 1, and extended it to include all the implementation for WASI sockets, and embedded it into their own compilation toolchain, and are using their own, now they are using their own WASIX interface. However, WASIX cannot be considered a standard, it's non-standard. However, it's like a workaround. While WASI is getting standardized, this can be used to experiment running HTTP servers on network server, any network server on WebAssembly. And what I use for my project is, I think, a better solution is to utilize WASI Preview 2 and a newly introduced WASM components. And components model for WASM modules where interface can be defined via WASM interface type. I will show how this interface type looks like. And this WASM components, basic idea is to divide WASM components into dynamically linkable parts, which can be executed in isolation from each other. However, they can be also statically linked via runtime. And here I have some thoughts that I will talk about later in the presentation, but this is just to consider now. And now, problem two is that WASM component model is not yet supported in major WASM runtimes. For example, WASM Edge is waiting for the proposal to be stabilized before implementing support for it, and there is an open issue about it. And the solution for me was to use instead WASM time runtime and utilize the tools provided by Bytecode Alliance. Bytecode Alliance is a non-profit working on standardizing a lot of features and creating a lot of tools related to WASI and WASM. So in my project, I just wrote some simple interface for my HTTP endpoint. It looks like this. It imports some types from HTTP types, which I also wrote down, and I will show it. And it imports the HTTP outgoing interface and exports the HTTP endpoint interface. And these are some types that are used here. And they are pretty low level, but is a list of bytes, and headers is a pair of is a list of pair of strings. And using this with interface and with bindgen on Rust, I was able to create a Rust macro which wraps around this function and then places it into the interface generated by with PineGen before compilation, and then compiles it into WebAssembly. And then that WebAssembly can be run by Wasmtime, which supports component model. So this is an echo example in Rust. This is a static page which embeds the whole index.html file into the bytecode. And then this is an example of outbound HTTP request, just forwards one request. Doesn't forward even. It just returns one request from one endpoint. So based on looking at, actually, before talking about this, I should show the demo. It'll take a minute. So I'm running a simple Node.js JavaScript server, and here are the interfaces that are generated by bytecode alliance tool, and it is interfacing with this WASM file defined here, which is generated, and I'm just using it for my endpoints. Very simple. So it is running on port 5000. I will show it now. So this is coming from WebAssembly component. This is a static page. And this is not really a proxy, but just forwarding outbound connection. Yeah, super simple.
I think that's worth an applause still.
Can I ask a question? If I understood correctly, the main issue or like the solution is that per se you cannot run this. You don't have like libraries to process a HTTP request, but by using the component and then including the component in JavaScript or whatever you're using, then you can compile it.
Yes, so basically I create, so the question was exactly how?
Yeah, like in the end the main solution is that you don't have libraries to process HTTP, but you can create a component and then include it as a library to have a WebAssembly that actually can process the HTTP, right?
Right. So yeah, I created my, so the question was, I'm not using any libraries for HTTP, and I'm just creating this WASM component and then wrapping around an HTTP server around it. And it is correct, yes, I'm just, so here request and response is just an HTTP type that conforms with Rust cargo for HTTP. And this macro on top of the function wraps this component into a component with a specified interface that I showed earlier with with. And this component is then compiled to WebAssembly, plain WebAssembly, with just interfaces for importing and exporting some functions. And I'm importing that WASM component into a JavaScript server, and then that server is then forwarding an is receiving the HTTP request and forwarding that into the WASM component. So works like that.
Is there a figure that illustrates that? Somewhere that I missed. You said this previously, but is there a figure that?
No.
Okay, it's chill. I was just curious. So,
Yeah, thanks for the answer.
Yeah, based on this, opportunities and threats for using WebAssembly is that it is a promising option for extending the capabilities of the cloud to the network edge, promising technology for distributing computer across edge devices. It is possible to create a common marketplace of cross-platform libraries and apps, and it can be integrated with existing technologies. And some threats is that it depends on the ecosystem of tools around WASM. As you can see, there are workarounds still, and they are incompatible with each other, and the standardization process is very slow. It is in early development with limited real-world usage. And as more features get supported by WASM and WASM runtimes, you might ask that we might have interoperability issues reintroduced later on in the development of this ecosystem. So there are current runtimes that you can consider, like this. WASM Edge, part of CNCF, WASMer, and WASM Time. Current tools that you can try to use and tinker with that I used for my project. And these are promising orchestration systems, much more sophisticated than what I wrote. So Spin is somewhat similar, also using WASM Time and their own components, and those components are then deployed onto their like host runtime that they designed themselves, and it is proprietary for them, but Spin can produce a standardized output of components. While WASM Cloud is a CNCF project and trying to integrate more with the Kubernetes and well, CNCF ecosystem. And these are the organizations and companies contributing to the WASM ecosystem, and those are the companies that I stumbled upon to while doing my project. So those you can follow. And the conclusions is that I have WASM is in very early stage development. It's a binary code that can be used to abstract away things at very different levels, down to operating system level, up to maybe creating a runtime on top of a cluster, and then this cluster distributes these WASM components across host devices to appropriate places. So yeah, thank you. Yes?
Is there a link to like an archive preprint, or are you planning on submitting this to specific conferences at some point, or is it under consideration for specific conferences?
Do you mean the bachelor's thesis itself?
No, I mean, has your PI like forced you to, to put this as a preprint at the archive or like some specific conference, or is this just a project you're working on?
Just a project.
All right, sweet. Very cool.
Did you publish it on Altus website or?
It is not public, but it is there.
I put mine on GitHub, so if you want to share it, and just put it.
You probably want to preprint.
Well, the thesis itself is very, like, because it's a bachelor's degree thesis, it's very simple, because I had to make it simple for bachelor's degree students. Otherwise,
But you shouldn't let that be like a limitation. I would like just submit it to a conference, so it'll be a proceedings or something. Like if it's on GitHub, that's bullshit. If it's a preprint, it's bullshit. If it's peer reviewed, it's not bullshit. So if you
well,
want to do that.
yeah.
Later,
Yeah, later.
You want credit.
Any other questions? Yes?
You talked previously about using
So the question was, I talked about the WASI interface and also the interface for accessing sensors. The one which is used for accessing sensors and IoT device peripherals is not standardized into WASI yet. And regarding the replacing the drivers for like I can imagine that a WASM runtime can have a configuration for replacing or putting an intermediate like eBPF between the runtime handling the WASI interface call, and at that point you can add some customizations, but it depends on the runtime if it supports it. Any other questions? Yes?
Are there any famous projects that use WebAssembly? Something that we are all familiar with?
Not that I can
What do you
think
mean
of.
by famous? Like, is there any publications on ACM or
So is the question, are there any production applications?
No,
or maybe on games like in a browser. I think something is
Oh yeah, well, WASM it is like what popular things exist that utilize WASM currently in the wild was a question. Well, here I talked about cloud usage, but of course WASM can be used for any other purpose like game development. In game development it is possible to compile C++ game into a WASM and then make it executable inside the web browser without having to cross-compile it into different machines or making executable, which is going to be untrusted by people. Like, why do you want to do that?
We
So,
will just use JavaScript. So we don't have to use that.
JavaScript for game development?
No, so we don't have to use JavaScript.
Oh yeah, right, exactly. Because you don't want to use JavaScript for game development.
Yeah, kind of following up that question, I guess it is in general WASM what is not stabilized yet, or is more like WASM for WASI part?
Oh yeah.
Because I guess if you are using for game development, it should be kind of
Yeah, so is WASM stable enough to use? Of course it is. Version 1 was released in 2018, if I'm not mistaken. Since then it is pretty much stable. Every application compiled to it works. It's just a matter of standardizing the interface for communicating with WebAssembly, and WASI is still being standardized right now, and it is difficult to use it.
Yeah, then thank you very much.
Thank you.
everyone. My name is Svetlana Chaplinska, and today I'm gonna talk about my thesis work that I did around a year ago together with Fractal, and it had a beautiful name of Purple Team Approach to Attack Automation in Cloud Native Environments. And we're gonna talk about some of the things related to the thesis and gonna look into the different current attack vectors in cloud native environments with kind of view through how we approached it in the thesis work. So to begin with, I have about myself slide. I like to talk about myself in 3 flags. It's Ukrainian, Finnish, and Swedish. So I'm Ukrainian. I did my bachelor's back home in cybersecurity, and then I moved to Finland to do my master degree in security and cloud computing. And today we discovered that we all just do a beautiful marketing campaign for Aalto University because all of us study in Aalto. And as it was double degree program, I also been to Stockholm in the KTH Royal Institute of Technology. And after moving to Finland, I had an internship in Ericsson as cloud security developer intern, and I have few of my colleagues here being my moral support. And now, the recent experience of mine was that I did my thesis together with Fractal as a junior information security researcher, and now I work with Fractal as junior information security consultant. And in Fractal, we do different types of information security consulting, and we strongly believe in cyber positivity and looking into security from a more positive angle of things. So let's go back. Yesterday, I asked colleagues how to make my presentation better, and we all agreed that good presentation makes a good humor in the presentation, but I'm not necessarily good in trying to add jokes to my presentation, so I decided to ask ChatGPT to make me a good Kubernetes or cloud native joke. And we all can agree that AI tools can be very helpful in different ways of our work, but it's not necessarily up there with the jokes. So the best one that was generated yesterday was, why was a cloud native developer always calm under pressure? That's very also positive of ChatGPT to think so. So the answer is because they know that even in Storm, their application will auto-scale to meet the demand. Thank you, thank you. All credit to ChatGPT. Now, as we're done with the jokes part of this conversation, let's move to what we actually had to be talking about. So let's talk about what happened into the threat landscape of cloud native in the past year and a half. I will not tell you anything groundbreaking. Everything you see on the screen is something you've heard about, and there is just some statistic that maybe I will throw here and there, but the main and common threats and recent attacks. So it all starts with misconfigurations that persist to be a very big attack and threat vector, and just all, like we all have to be mindful that those are happening, and we have to automate all the possible validations so we can avoid as many of those as possible. Then moving to supply chain attacks, of course, all of the software now is built of some building blocks, and we utilize some public open source projects. And for example, Aqua Security did this interesting statistics that in 2022, 61% of all of the images pulled from Docker Hub was from public repositories, and it was 15% increase compared to 2021. And as we know that a lot of those images, public ones, they have some malicious components, and users are not always mindful about their actions. And then the next one, also not going to be surprising that the software has a lot of vulnerabilities. They keep popping up. And Palo Alto Networks recently published a research that 96% of third-party container applications deployed in the cloud infrastructure, they were found to contain known vulnerabilities. So that does something to think about. And from the more attack vectors, so crypto mining still persists to be a very big attack vector. Aqua Security last year also published research that for every $1 of adversary, like every gained $1 for adversary, they have to bill at least $56 from the victim, which is slightly a crazy correlation. But then we have data breaches, and when we talk about cloud native environments, we have this additional concern that sometimes adversaries can swing in the environment and being unnoticed. And then the last but not least, we have DDoS attacks. So they increase their popularity, and especially when Ukraine-Russia war started, there was a very significant increase into the DDoS attacks. So it increased from 8 to 34% in the Q4 2021 to 33 in Q1 2022. And a lot of those attacks were utilizing containers that were hosting on public repositories to make DDoS attacks easier. So now let's discuss two different attacks or just events that happened recently, just to have a grasp of how they are looking nowadays. So the first one was a research also from Aqua Security. So they discovered that 350 organizations, which include some of the Fortune 500 companies, they have their Kubernetes clusters openly accessible and unprotected in internet. And at least 60% of them, they were breached and have some active campaign deployed with some of them had backdoors. They analyzed them further, and the main takeaway here was that most of them were due to two main misconfigurations. So the first one was allowing anonymous access with privileges, and the second one was running kubectl proxy with arguments that allowed, that exposed the cluster to the internet. And another observation that they made was that a lot of those were open source projects. And if we talk that the open source project is compromised, that can trigger a big supply chain infection vector, and then it can affect more and more users around the globe. And the next one will be more cloud related. So I was calmly having this presentation ready yesterday, but Microsoft published their investigation about this just yesterday before I was going to sleep. So I had to update this slightly. So there was an incident from the Chinese threat actor Storm 0558, and then acquired Microsoft account consumer key, and with that key, firstly, it was reported that they were able to forge access tokens to the Outlook web access as well as Outlook.com, but as the investigation was going further, it was discovered that with that forged access tokens, they were able to access various Azure Active Directory applications, and those included personal Microsoft accounts like SharePoint, Teams, OneDrive. And yesterday, Microsoft published their technical investigation of the issue. So they reported that the key was exfiltrated, probably from the Microsoft engineer's corporate account, and the key was leaked there as part of the crash dump that was there for investigation. So that's just something to digest. And now moving to when we are discussing all of these different attacks, how do we approach the analysis of those? So there are two different methodologies. So it's cyber kill chain, which is the first way to approach attack analysis, and MITRE attack framework. So cyber kill chain splits attack into 7 distinct phases. So it starts with reconnaissance and ends with actions on objectives. And now more common way to think about attacks is using MITRE attack framework. So they have more granular approach to the attack analysis, but it can be mapped to the cyber kill chain phases. But today we're gonna talk a bit more about MITRE attack because how we approached it in the thesis was very related to MITRE. So MITRE is a knowledge base of adversarial techniques which are based on the real-world observed attacks. And here attack stands for adversarial tactics, techniques, and common knowledge, where tactic is the goal of adversary during the attack, and technique is how adversary can achieve some certain goal. So this is the minor attack metrics that they publish for different environments. So you can see all of those different, so the boxes are ways of achieving the goal, and the titles are what are the goals. So reconnaissance, initial access, execution, etc. And when thinking about the thesis topic, we encountered the problem that when we think about cloud native environments, it's a combination of cloud containers, CI/CD pipeline, and there is no one place where you can find the thread data specifically about cloud native environments. So we tried to resolve that problem, and we've got a solution which is a cloud native thread matrix. So it has 125 different techniques that are relevant to cloud native environments. And the primarily sources there are MITRE ATT&CK framework and different public research reports, such as Aqua Security. And if you had to get a takeaway from this presentation, there is a Hacking Kubernetes book that I would very highly recommend if you want to get either familiar or just enhance your Kubernetes security knowledge. So I would highly recommend that. And this is the cloud native threat metrics. So we have all of those MITRE-looking metrics with different techniques that are relevant either to cloud containers or CI/CD. And we have more of the description of the technique and what are the sources and what it is relevant to. And moving forward, we were thinking that, okay, we have cloud native application or the system. How do we improve defense capabilities of the system? And here I will introduce the purple teaming. So in information security, we usually split people to red and blue teams. So red is the offensive team. So those are someone who will perform some tests on the environment. And then we have blue team, who is the defense part. So they will be the one to monitor different system activities in order to detect maybe there is something malicious happening that can be an indicator of some compromise. But usually the problem is that red and blue team, they're not really working closely together, so it's hard to effectively improve the defense and response capabilities of the system. So that's how purple teaming was introduced as a concept. So the main idea is that the red and blue team will work closely together, and the blue team will in real time monitor either they can detect some type of attacks, and then they will try to improve the defense and response capabilities, but already in more effective manner. And next one, I will introduce also the assume breach and defense in depth context. So previously we were talking about security more, that we have to secure the outer layer of our application to prevent the breach from happening. So we just try not to let the adversary in the system. But as the vulnerabilities and attacks are getting more complex and advanced, we understand that the outer layer of security cannot be relied on. So we assume the breach. So we accept that adversary is already in the system, and we test, we focus our testing on checking the protections inside. And the main goal here that we just minimize the final impact on the system, because we understand that it's almost impossible to just assume that our system will never be compromised. And it all helps us to build this defense in depth. So building security in a layered manner. So we accept that if some controls, some security controls fails, we have something else to back it up. And then how do we make sense of all of those different techniques so they can be chained into the attack? So the adversary will, so we assume that adversary is already somehow got into our system, so they got initial access, and then they will execute different techniques. So they will do something in order to make a final impact. And what do we want to do in our system is to check either we can either detect or protect it from these different steps execution. And then thinking how can we do this testing better is of course by introducing some automation. So the second part of the thesis work was creating an automation tool. There are already several tools available that can do similar things, but in our case we had already an internal solution which was capable of some of the things that were required, and the most straightforward way was just to take that solution as a base and then build up on it everything that we envisioned in this more cloud-native way. So it's a Go-based application, and it has automated attack techniques from the cloud-native threat matrix. It's containerized with Docker, so it can be deployed in the target environment, and we have a script runner for deployment and execution of it in the target environment. And here was our test environment. So we have our target system, which is basically an AWS EC2 instance. We have the Elastic Container Registry that has our attack container image, and we have our Bastion host where we have our script runner that deploys the container in the target system as well as triggers the attack execution, and we can see all of the logs and results of the testing back on the Bastion host. And then to make this puzzle all back together, so having cloud-native threat matrix allows, so here we are talking it in the context of purple teaming engagements. So it shortens the time for the testing preparation because we have all of the cloud-native related threads in one place. So automation tool, of course, increases maturity of such engagements because such a test can be rerun, so then we can, for example, avoid reintroducing some security flaws because the same test can be run several times. And then both Cloud Native Threat Matrix and the tool have ways to build up on it because it will not be relevant if it was just created and never updated because those threads are constantly evolving, so you can easily add new items to both. And then this all just make Purple Team engagements easier and more straightforward in the cloud-native setup. And to sum it up, cloud-native threat landscape is a huge area with something happening every day, like Microsoft publishing the investigation the night before the presentation. And yeah, I hope you learned something interesting, and if you have any questions, welcome to ask them.
So these are trivial questions, so don't worry, but like, can you say more about this internal tool? Like I know Google has the Lighthouse or something, and you can't see what it is. Like, can you say more about the internal tool? And is Purple Team something that's also internal? I've never heard of Purple Team, but it's like a pretty cool concept. In Microsoft, their support is terrible. Like the Microsoft Research Theory Group is terrible for their support. Like, yeah, I can't even submit my camera-ready paper that was accepted on the CMT platform. And like, there's errors everywhere. So like, can you say more about the Microsoft thing and those other things?
Yes, so the question was, tell more about the internal tool, and the second one was
the notion of like
the purple team, either it's something secret or it's a public concept. So the tool is just like a way to automate attack execution. There is not much probably to add to here. It's just something that automates execution of something, and Purple Team, it's not a new concept anymore, but it's just more like modern approach to security testing of the systems, just to make them more efficient for both the people who execute the testing and the platform or solution who is getting tested.
Got it. Sounds good. Cool.
So is this tool open source, or is this something what you use internally?
So the tool we use internally, and the threat matrix is published on the Fractal's GitHub.
For the schema that you use to somehow map the attack on the different phases of the attack. There was a slide that was saying from theoretical to, I think it was after that. Yeah, this one. Theoretical. From execution to impact. So here there is the at least I see an assumption that is not written, that the attacker has access to the Kubernetes APIs some way. Because if the attack starts with scheduling a new job, then it means that the attacker has access to the APIs. Do you think it's okay to assume that? Or can we find some other scenarios in which an attacker doesn't have access to the APIs, but still can harm the system?
Yeah. So in this case, we assume the breach and we kind of pick the point where we assume that adversary already reached some point, and then we build the attack chain starting from that. But of course, you can start even from the start of thinking how the adversary will break into the system and what will be the steps to get to the execution step, for example, so having access to any Kubernetes APIs or anything. So it's just like how you decide to build it. There is no rule to it.
Did ChatGPT make that typo, or is that you? Ransomware.
It was me, and then it means that it's also in the printed thesis, so that's okay.
Okay.
It wasn't still a ChatGPT time, that's why I'm very proud of my title, because I did it myself. But yes.
Yeah, I have a question. You mentioned you are testing this framework. So let's say with this latest Microsoft report of this attack, what exactly do you test? Do you have like the malware and you run it on the testing platform, or what is the testing doing?
So the test, we just wanted to have the core information that we can automate different techniques. So not all of the purple team engagement have to be manual. So it was just to test that, okay, we have this tool and we can take some techniques from the either MITRE or the metrics that we have, and we can execute it in some test environment. So with a Microsoft case, you cannot really replicate it, but you can of course take some known attack and try to split it into the attack phases and try to automate it as the attack chain is discussed here.
Okay, thank you.
Any more questions? Yes.
About the tool, do you run the tool one-off, or do you schedule multiple runs of the same tool? Because of course at time zero there might be all the defenses in place and you find nothing, but then maybe a new colleague arrives, like a master after his master thesis, and this colleague doesn't
Very
know,
good after our master thesis.
that doesn't know very well how to play with Kubernetes and then break something, so perhaps it would be better to...
So we don't have the way to rerun it in the scheduled way, but yes, that makes sense. That the idea of automation is that you would rerun it several times if you think that it's applicable case to see either your system is resistant or not. Any more questions? Thank you very much. Now you can enjoy the rest of your evening. Thank you for coming.
Thank you, and thanks for participating in the meetup. We still have some pizza and beer, so